Good afternoon. Once again, I heart to welcome all the participants of this webinar. This is a time of first session, and the speaker of first session is Dr. Balasubrahmani K. And I request Dr. Santosh Zamre sir for the introduction of first session. Please, Dr. Santosh Zamre sir.
Hello, good afternoon everyone. I am Dr. Santosh, standing in front of you to introduce to first resource person Dr. Balasubrahmani K of today's webinar. He was born in 1982 in a village of Karur district of South India. He earned Bachelor of Geography from Bharatidasan University with first rank and Master in Geography from Madurai Kamraj University with first rank and distinction. He had cleared national eligibility test for a lectureship in 2005 conducted by UGC New Delhi. He started his career as a spatial data engineer in a private software company from 2006 to 2009 and handled various 3D mapping projects with a capacity of team leader. Later on, he joined Bharatidasan University in 2011 and worked as assistant professor until joined the Central University of Tamil Nadu in 2017. He taught the courses related to physical geography, disaster risk management, and Geoinformatics to MSc, MTech, MPhil as well as PhD students. He has completed doctoral level research on evaluation of land and water resources, of semi-arid watershed, of sustainable development at Madurai Kamraj University in 2016. He was trained at Indian Institute of Remote Sensing, that is IIRS, National Institute of Disaster Management, that is NIDM, and GIS TDA, Ministry of Science and Technology, Bangkok of Thailand. He extended his contribution to professional societies including IRS, IGS, and GIS and coordinated various programs. He is recipient of Young Geographer Award from the National Association of Geographer, India, and Young Scientist Fellowship from TNSCST, Government of Tamil Nadu, to carry out research at Indian Institute of Space Science and Technology. His current research focus on exploring application of geospatial technology in interested risk assessment, watershed modeling, and land use planning. Finally, I request to Dr. Balasubrahmani K for his valuable guidance.
Namaskar.
Thank you, sir.
I am K. Balasubramani from Central University of Tamil Nadu. Welcome to the national webinar on Geoinformatics and Disaster Management, being organized by Yashawantrao Chavan, Warana Mahavidyalaya. I thank the organizers, both IQAC and Department of Geography, for inviting me to deliver a special lecture on Geoinformatics and Disaster Risk Management. I hope you will enjoy this lecture. This lecture will teach you about various concepts associated with the disaster risk management, as well as applications of geoinformatics in disaster risk management. Once again, I thank the organizers for inviting me and thank all the participants to register for the webinar and joining with us. Thank you.
Welcome to the lecture on the disaster risk management. The lecture consists of two broad aspects. One is about basic concepts in disaster management, and another one is a role play of geoinformatics in disaster risk management. I don't need to explain you about the word disaster. I hope everyone aware about it. Disaster is a serious interruption which affect functioning of a community or society, as well as which creates a widespread human, material, and economic and environmental losses. Of course, this kind of interruption happen every day, but which deviates the regular happening from disaster is the ability. If any interruption exceeds our control or exceeds our ability, and which is called it as disaster. When I say exceeds our ability, and disaster become a scale dependent. Say for example, if disaster occur at a local level or village level, and village people all they put their resources to control the serious interruption, but of course they could not able to do it or control it or contain it, then it call it as village level disaster or local disaster. If a situation happen which creates a serious interruption to the state resources and state government put all the effort but it could not able to control it, then we call it as a state disaster. Likewise, say if you talk about the COVID, this is a biological disasters which create a widespread human losses and as well as indirectly economic and environmental losses as well. But all our resources, whatever we put, we could not able to like control or contain it. Then it is called it as international disaster or global disasters. So that's why we call it as a pandemic. So disasters are always scale dependent. It should be defined in terms of the ability of affected community or society. Disaster risk, it's a combination of probability of an event and its negative consequence in future. It is usually associated with the degree to which the society cannot cope up with a particular situation. It may be natural hazards or man-made hazards or biological hazards. This disaster risk has three elements or variables, namely vulnerability, hazard, and capacity. So the disaster risk is always estimated by this formula, vulnerability into hazard divided by capacity. I will explain here about the risk factor. Hazard, it is a phenomena that may cause a loss of life or injury or property damage or any loss of livelihoods or services or environmental damage. We call it as a hazard. Say for example, cyclone, it is a hazard. And vulnerability is the characteristics and circumstance of a community or system or asset that is exposed to a damaging effect of a hazard. Say for example, if a village exposed to a cyclone, that exposed village or exposed people or exposed asset, here we call it as vulnerability. So one side we have hazard, another side we have vulnerability. The product of hazard and vulnerability determining the risk. But if we have a coping capacity, which refers to the ability of a people or organizations or systems, with the help of available skills and resources, if we could able to reduce or mitigate the adverse conditions of an dangerous phenomena or exposing like a community, then that we call it as a coping capacity. This coping capacity always contribute to the reduction of disaster risk. So that becomes a denomination factor. So for example, if you have like 2 units of hazard, just for understanding I should say, and 2 units of vulnerability, and our risk is 4 unit. But if you have a 4 units of coping capacity, you can able to like manage the situation and risk become null. But in normal conditions, hazard and the product of vulnerability always greater and greater, but coping capacity always a partial. So this coping capacity reflect in terms of absolute disaster risk. If coping capacity is almost nil, then the disaster risk will be very higher. And coping capacity is very strong and very powerful. And although there are dangerous phenomena continuously occur and people exposed, but due to this coping capacity or ability of the people, the disaster risk can be minimized. Here, I want to differentiate hazard and disasters. The left side you can see a river which is overflowing, and we used to say a flooding. If flooding happen without any like interruption of human society, then we never call it as a major disaster. But if flood meets the society and which will affect people or which will disturb the people, so here we call it as a disaster risk. If it is happened, we call it as a disaster. So hazard whenever meets the society, then it become disaster. So when you want to manage or understand disaster, we should know both aspects, both hazard aspect as well as the society aspect. Already I told you society has two aspects. One is just exposure vulnerability, and second or rare side of the coin is coping capacity. So when you want to manage the disaster risk, then definitely we have to understand the characteristics of both hazard as well as the characteristics of vulnerability and coping capacity of the people. And again, one more thing important is disasters are real historic events already happened, whereas risk is the probability of a disaster in the future. So when you want to manage the disaster in future, then we have to study in detail both hazard as well as vulnerability aspects, including the characteristics of coping capacity. Just to recap, if I ask you which river of these two has the greatest potential for flood risk, and your answer would be or should be this Ganga Brahmaputra Delta. Why? Although this Lena Delta in Siberia producing or creating flood events regularly compared to like Ganga Brahmaputra, then the flooding events are like higher over like Siberia, but still this population exposure is limited here. Population density is very less, maybe like 1 or 2 per square kilometer. Whereas if you take Ganga Brahmaputra Delta, especially if you take Bangladesh part, the population density is more than 2000 persons per square kilometer, which means that the population exposure or vulnerability is high and high. So the risk is the product of hazard and vulnerability and divided by coping capacity. Bangladesh is a developing country, so coping capacity also limited, which leads to higher flood risk. In the way, we can able to calculate disaster risk for any natural hazards or for any society. So this hazard, vulnerability and risk, all three are highly associated. If you have a low exposure and to like hazard, then the risk is low. If people exposed very high and the intensity of hazard also very high, and it become high risk, and in between the moderate or medium risk will fall. The coping capacity is normally studied in terms of resilience. Resilience is nothing but an ability of a community to bounce back to its original state after a hazard. Say for example, an earthquake occur in a place. Immediately the level of functioning of a society reduced from 100% to say 10% or 20%, and how they are coming back, that determines or shows the resilience. If they're coming back very quickly, then we call it as resilient community. Again, the level of coming back also important. If they are coming back quickly to the same level, 100% of earlier state, then we call it as resilient society, very resilient society. And some of the states or some of the like community may come back with a higher level of functioning compared to pre-state of hazard conditions. So that shows that an advanced resilience or very high resilience. So that such kind of resilient communities we would like to have it, because the disaster effects can be minimized or mitigated. But countries like India or countries like Africa have very less coping capacity or resilient power. So they could not able to come back to the original like state of functioning. Rather, they attain a partial build back and try to adapt the same level. Again, if next hazard happen to the same society or community, and again their like function will reduce. Like this kind of like effects ultimately will lead to a lot of like other problems, and sometimes the society may disappear from the world. So making the community very resilient is very essential for disaster risk management. Two more words always considered as synonyms, but there are subtle difference. Those are emergency and disaster. Emergency, it's nothing but a situation which is generated by any real or imminent occurrence of an event which requires our immediate attention. If an event which causes negative impacts, and again that impacts we could not able to control it, then we call it as a disaster. So simply say all like hazard initially start as an emergency. When emergency beyond our control or community or governance, and it becomes a disaster. Say for example, if you take COVID as a case, in initial stage the country like contained or like arrested the spread of diseases. We call it as just an emergency situation, health emergency situation. Thereafter, no effects at all. But when if it is beyond our capability, then it become a disaster. Of course, it spread throughout the world and it become a global disaster now. All the disasters just are a deviation of the natural processes. Say for example, if you talk about rainfall, rainfall have a two sides. If rainfall is excess, it become flood. If rainfall deficient, it become drought. So this is the normal conditions. All this deviation decides whether it is a disaster or not. Say for example, if in a particular year this rainfall exceeds, but still people can able to like manage it, then we call it as simply disturbances. But if the same deviation beyond our like a coping threshold, beyond that, all river can't like carry such kind of water, and it is like overflowing and inundating the surrounding regions, and people suffer out of it, and beyond our manageable limit, then it become a flood disaster. Likewise the opposite, the drought. So all hazards are disasters, just deviation from the normal. So we have to keenly monitor our natural process, as well as we have to support the natural process. If we are going opposite to natural process, and of course, no doubt about it, disaster will be resulted. There are broadly two type of hazards or disasters, which includes natural and human-made. Natural, I no need to explain you much. You are all aware about it. Amongst natural hazards, the most important one is flood. Almost 40% of the world population affected by a single disaster, that is flood. flood is a common problem in almost all the countries, especially in low-lying regions. Of course, low-lying regions are preferable sites for human settlements as well as for human economic activities. So the floods are inevitable. In addition to flood, the coastal regions severely affected by cyclones. Cyclone is the second most dangerous disaster, which creates widespread losses throughout the globe, especially over coastal regions. So these coastal regions experience both flood as well as cyclone, which requires a proper monitoring and management of disaster, or otherwise the loss of lives and loss of property will be very high. Interior pockets and away from major source of water or major river basins, and you could find the phenomena of drought. Drought is the third most important disaster or hazard, which affects mainly these semi-arid regions because those regions depend on rainfall. If there are slight changes in rainfall in a year or in a season, which resulted drought. If it is continuous for years together, 3 years, 4 years, and of course, no doubt about it, drought will be persistent. And if it is continuous for a decade and it become like famine and hunger will be resulted. So drought also serious problem in most of the developing and underdeveloped countries. Earthquake also an important issue wherever the active tectonics happen, especially plate margins or like very high fold mountain regions. So those regions, uh, of course, have a dotted events of earthquakes, but which kills thousands and thousands of people. This is also very important, like a disaster, and it is very unpredictable. Although the area can be demarcated where the chances of earthquakes are high, but saying in advance about the happening of earthquake, it's very difficult still. Tsunami and under ocean earthquake will resulted in huge waves. We call it as a tsunami, which may be generated in one part of ocean, but which will propagate through the water body and hit many like coastal areas. Say for example, 2004 Indian Ocean tsunami started from Indonesia and traveled thousands of kilometers and hit India and created more than 10,000 loss of lives. So this is one of the major killing disaster or hazard over a coastal area. So proper monitoring and preparedness is very important for managing tsunami kind of hazards or disasters. Hilly regions have a peculiar problem of landsliding. This is again an important issue. And of course, landslide have a high correlation with flood as well as earthquake. So both flood and earthquake will kindle landslidings. And of course, sometimes this landslide will damming the water and create floods. So these three are highly related and which is creating widespread loss in hilly regions. This is also an important problem for hilly regions. Biological disaster until 1930s it was familiar and it is the like a killing disaster. It was the killing disaster. And of course, due to medical advancement, we reduced the impact later on. But again, the history repeats through COVID. So this is also a very important disaster which kills lakhs and lakhs of people compared to all other disasters. If you talk about the number of disasters, until 1970s, the number of disasters are less. Thereafter, the number of disasters are increasing. This is mainly due to two things. One is the increasing population. Already I told disaster, it's nothing but a product of hazard and vulnerability and coping capacity. So after 1970s, then population boomed which leads to more exposure of population. So even small deviation which leads to major disasters. And second reason is the climate change, human induced climate changes. In addition to natural changes in climate, this human actions also lead to a lot of accelerated changes, which leads to then various spatial problems of hydrometeorological disasters. So which leads to more number of disasters after 1990s or after 2000. Deaths due to disaster in the early part of last century it was very high per annum, but later on due to medical advancement we reduced. But again history repeats. Now if you plot it in 2020 it will again high, and if it is continuous again this cycle repeats. So this is also serious problem because lives are precious. In addition to problem of life loss, then the major problem of disaster is number of people affected, either directly or indirectly. If you talk about total people affected by a disaster, before 1970s, very limited, less than 50,000 per annum. But now it exceeds like 3 lakh or 4 lakh or 5 lakh per annum because of increasing events of disasters and increasing exposure of population with low coping capacity. Damage, again, it is one of the important factor nowadays because each and every disaster creates widespread economic loss. Again, we have to spend a lot to build back. So this is a serious problem, not only in developing and underdeveloped countries, even in developed countries as well, where the damages due to disasters also increasing year by year after 1990s, especially due to hydrometeorological disasters. So this is also one of the important problem to look at. So far we discussed about trends of disaster in at world level, but why disaster matters in India. So why we need to concentrate much on disaster management or disaster mitigation or reduction? Because if you look at the multi-hazard risk in the map, in this world map, you can see almost most of the part of India comes under high risk category. India is like a second most populous country. Of course, if you consider both hazard as well as a population, and we are the second most hazardous or risky country in the world next to Bangladesh because of high population density and frequent occurrence of many disasters. So disaster management is very, very important for Indian case. Again, it's not about just understanding the characteristics of hazards, rather in Indian scenario, which is very much required to study in detail the vulnerability. Vulnerability matters here because vulnerability is the core for many kind of impacts. Again, if exposed population have a kind of resistance to exposure or resistance to reduce economic or life loss, then that would reduce the overall impact. And again, the people exposed are resilient after a disaster. They could able to come out from the crisis with their own resources. Then the problem of like burden to the governance will be reduced, so which will not disturb much the economic system. So these, in addition to exposure, resistance and resilience of population is very much required. Generally, there is a myth that poor who tend to suffer worst. Of course, in most of the cases, it has been proved. And again, the disaster often associated with certain groups. Say, for example, marginalized community, old age people, children's, women's, disabled population. These are all the groups tend to suffer always due to disasters. So providing like proper infrastructure to those kind of groups or marginalized group or poor, and make them a resilient community is the challenging task to the governance, which requires more research than just to analyze the direct impacts of a hazard, which requires a systematic management process. Please note that disaster cannot always be prevented, but the adverse effect can be minimized through improving the resilience of the population. And disaster should be viewed, it is more than just response and relief, whereas countries like India still look at the aspect of just providing assistance or response and relief after a disaster and forget about it afterwards. So we need a systematic disaster risk management process. Here, I would like to emphasize that the hazard which can't be prevented, it used to happen, but we can improve or reduce the people exposed. If people exposed directly to the hazard, then definitely risk will be resulted, high risk will be resulted. But if we improve the resilience of the people or society, if we improve their coping capacity, then they can able to control or manage themselves. Disaster can be managed by preventive actions like stopping hazards to occur, or just strengthening the exposure, or strengthening the population by adding more resistance and resilience. We call it as mitigation activities, either through structural activities or non-structural activities. As well as in certain cases, we have to emphasize more on preparedness, because certain things you can't even minimize it or mitigate it using structural and non-structural actions, but having a proper preparedness plan, we can able to safeguard the people as well as economic loss from economic loss. So improving resilience among the exposed society, it's very much required for all these scenarios, including prevention, mitigation, and preparedness, ultimately which will reduce the impacts of disaster. This requires build back strategies, better strategies, for which we need a systematic risk governance. Please note that every rupee invested in prevention and preparedness can save up to 7 rupees in damage reduction. So better in prevention and preparedness will reduce number of events occur, and then even if events occur or disaster may occur, then the impact will be very less. Even the impacts are there if you already prepared a people to tackle it, and they could come out their own with their own resources. So the burden on governance, especially on government, will reduce, so which require a proper systematic risk governance, for which now people widely using the geoinformatics. Geoinformatics are technological synthesis of various technologies including geographical information system, remote sensing, cartography, informatics, geostatistics, and GPS and other surveying equipments. All if we put together, which can be used wisely to manage the disaster situations. And again, this geoinformatics is powerful tool, not only just to model or predict the scenarios of hazard, as well as which is also a powerful tool to understand the exposure of the population and their vulnerability. And we can use it on various dimensions, including human dimension, ecological dimension, economic dimension, infrastructure, and political dimension as well. And geoinformatics can be used at local level, regional level, national level, even at global level. So geoinformatics are key. Geoinformatics tools are key for many disaster management activities, including early warning systems. Early warning systems earlier just like developed with the help of like communication systems, but now with the help of like geoinformatics, we can able to like precisely monitor many hazard events. And if we have a proper database in our hand, and we can able to identify who are like, exposed to such hazard, and accordingly we can like inform the people so that they can safeguard themselves in this manner. Now early warning systems are widely using geoinformatics, which is very much essential for like minimizing the effects. Geoinformatics is also useful especially for mapping hazard events. Say for example, by mapping the earthquake, we can able to understand the region which is very prone to earthquake. Just to track the cyclones and map it, we can able to understand which region is frequently affected by the cyclone. Okay. So like we can map all the hazard events, and we can put together all together on a spatial domain, and we can able to understand the like impacts or exposure. And geoinformatics also very powerful for hazard assessment. So for example, I have attempted a flood hazard mapping for a Karur district just with the help of a digital elevation model and like rainfall data. Based on that, we could able to stimulate it, and we can able to understand which pockets will severely affected by flood events, because topography is a strong controlling factor of occurring flood. So by understanding the contributing or controlling factor, we can able to understand the region which is prone to different hazards, which is applicable to natural hazards or man-made hazards. All the things we can able to map it. And of course, if we do it for all individual hazards and combine together, and we will get a multi-hazard assessment also, which is also very much required to have a holistic disaster management plans or like scenarios. Say for example, for coastal Tamil Nadu, I have attempted mapping of different hazards including cyclone, coastal erosion, flood, drought, earthquake, and we can with the help of multi-criteria addition tools, and we can combine all these things, and we can able to understand multi-hazard scenarios also, which is very important for taking up many disaster management plans. And of course, with the help of mapping hazard events and with the help of hazard assessments, we can able to do hazard zonation. This is also very important. Say for example, these are all the packets which affected by 2004 tsunami, and we can mark it that these are all the like extremely dangerous zone for like future tsunami. And there are probability that also we can model it based on like changes happening over land use, land cover, and that also we can incorporate it in our zonation. So like based on past events, we can zonation, we can prepare a zonation, as well as by including likely changes in future, we can extend our zonation and we can safeguard the people. Like with the help of geoinformatics, we can able to do a better like hazard zonation, which is very much essential for like taken up very constructive steps to reduce disaster impacts. Of course, there are different techniques available for zonation of individual hazards. Say, for example, landslide, if you talk about, I have attempted with the help of digital elevation model, drainage, geology, rainfall, like NDVI, which is the proxy of vegetation, soil, and slope, and based on even other parameters extracted from satellite data. All we can put together and we can model it, and we can able to like create hazard zones. So for example, this green color shows low hazard, whereas red color shows high hazards, and these dots are already occurred landslide locations which have a good what I say uh, accuracy, and we can like use it for planning purpose. So say for example, if new development infrastructure projects may coming up in these high hazard zones, and government can restrict and so that we can reduce the impacts in future. So like these hazard zones helpful in many aspects of disaster management. In addition to simply hazard zonation, this geoinformatics also useful for hazard modeling, which is very much required in present scenario. So for example, if we have a proper map or like details of urban setup, and we can able to like stimulate it, if there is a breach in this place, what are the reasons will be affected, okay, and which are all the place will be like severely affected. Even if the breach we could not able to control it because of natural process, and breach would like often occur, then we have to safeguard these people before like a rainy season or before peak flow of water, okay, for which we need evacuation shelters. That those evacuation shelters then we can establish here, because these regions have very less probability of getting like a floods, so that this evacuation shelter will be in a safe place, which will reduce the impact. So like this hazard modeling helps in many like aspect to reduce the disaster risk. Geoinformatics not only helpful for hazard assessment, even which is now widely used for vulnerability assessment also. Say for example, we can do survey of each and every like individual houses and their exposure to different hazards, and we can do like a lot of questionnaire survey, and based on those like details, then we can able to like delineate which are all the regions have very less exposure, and which are all the like pockets or like houses are highly exposed uh, to a certain like hazard, and what is their like a level of exposure, level of resistance, level of resilience. All the things we can model it, and we can able to formulate or identify the risk curve, so that we can even estimate economic loss and other losses based on return periods. So within 10 years, how much of like loss would happen? Within 50 years, how much of loss would happen? Like all kind of vulnerability assessment also now aided by the tools of geoinformatics. Say for example, I have attempted a vulnerability assessment for a Karur district on various aspects, including flood vulnerability, drought vulnerability, dengue vulnerability, then even man-made vulnerability, and all put together with the hazard again, and we could able to find out multi-hazard vulnerability. Say for example, a district collector want to establish a proper plan district disaster management plan, and want to like reduce really the number of disaster events in a district, and they can use this kind of maps, and they can deploy the resources, people, governance, and through better like planning or better preparedness, we can able to reduce the disaster risk. Disaster like always create damage, and geoinformatics helps a lot to map or assess those damages. Say for example, this image shows before tsunami and after tsunami of 2004. We can very simply or very like efficiently we can able to understand the damage induced or like created by the tsunami. Like say for example, this is another like image, and this is a flood of Kerala, in 2018 before flood and after flood, which pockets severely affected. So all the things we can precisely monitor or assess it through geoinformatics. And of course, it's not only just simply comparing what is a pre and post. Rather, some of the missions continuously monitoring the hazard events and its impact, so that we can understand the various aspects of a disaster impacts, which is now fueled by the tools of geoinformatics. And this kind of assessments, just not at local level or national level, even certain things can be happened or can be assessed at global level. Say for example, the Sentinel-3 emissions continuously monitoring all the fire events, and there are systems developed by European space agencies which could monitor all the fire events across the globe, and they lively update the data which can be used for various planning purpose. By recognizing its potential, the SENDAI framework highly recognized the use of geoinformatics in reduction of disasters, and they have already designed targets to achieve by 2030 to sustainably substantially reduce global disaster mortality, number of people affected, economic loss, damage to critical infrastructure and services. All this can be planned or can be attempted with the help of geoinformatics. Not only reducing this aspect, rather increasing the number of countries having disaster risk reduction strategies, and increasing cooperation in developing countries, and increasing availability and access to early warning systems and disaster risk reduction information can also achieved with the help of geoinformatics. Simply geoinformatics never helps a proper or efficient disaster management. Rather, we need a community-based disaster risk management with the help of geoinformatics. This combination, community, systematic governance, and geoinformatics, definitely will reduce or improve the disaster risk management, which requires uh, in the present century, because the number of disasters are increasing and impacts also increasing, and damage, socio-economic loss also increasing. So all this to be controlled, which requires a blending approach of community-based approach, systematic governance-based approach, and geoinformatics-based approach. This blending definitely will reduce disaster impacts. With this information, I am thanking all of you for patient listening this lecture. Of course, you should join your hands to build back better with the help of geoinformatics. I hope you have enjoyed this lecture. Any comments if you have, and any questions if you want to ask, please mail to geobalas@cutn.ac.in. Thank you.